Hello friends, welcome to the learning series on the great scientists and technologists of the world. Today we are going to learn about the James Clerk Maxwell, one of the most famous and renowned scientists of the 19th century. Kindly watch till the end to learn about the James Clerk Maxwell. James Clerk Maxwell, a Scottish physicist, developed the classical theory of electromagnetic radiation, describing electricity, magnetism, and light as distinct manifestations of the same phenomenon. Maxwell's equations for electromagnetism have been called the second great unification in physics, where the first one had been realized by Isaac Newton. If you are new to the channel, kindly subscribe and click on the bell button to get our subsequent videos. Let's go into the video. James Clerk Maxwell, born on June 13, 1831, in Edinburgh, Scotland, was a Scottish physicist best known for his formulation of electromagnetic theory. He is regarded by most modern physicists as the scientist of the 19th century who had the greatest influence on 20th century physics, and he is ranked with Sir Isaac Newton and Albert Einstein for the fundamental nature of his contributions. Maxwell came from a comfortable middle-class background. The original family name was Clerk. The additional surname was added by his father, who was a lawyer, after he had inherited the Middleby estate from his Maxwell ancestors. James was an only child. His parents had married late in life, and his mother was 40 years old at the time of his birth. Shortly afterward, the family moved from Edinburgh to Glenlair, the country house on the Middleby estate. At 16, Maxwell entered the University of Edinburgh and published 2 scientific papers. He later went to the University of Cambridge, where his exceptional powers were recognized. His mathematics teacher, William Hopkins, praised Maxwell as an extraordinary man but noted his deficiency in analysis. Maxwell's preference for geometrical methods was reflected in his formulas that obtained correct results from faulty mathematical arguments. His exceptional abilities were later reflected in his significant contributions to mathematics. In the next 5 years, he published 2 classic papers on the electromagnetic field, demonstrated color photography, and was elected to the Royal Society in 1861. He also conducted theoretical and experimental work on gas viscosity, leading to a lecture in 1866. He supervised the experimental determination of electrical units for the British Association for the Advancement of Science, leading to the establishment of the National Physical Laboratory. In 1865, Maxwell resigned his professorship at King's College and retired to the family estate in Glenlair. He continued to visit London every spring and served as an external examiner for the mathematical tripos at Cambridge. In the spring and early summer of 1867, he toured Italy. But most of his energy during this period was devoted to writing his famous treatise on electricity and magnetism. It was Maxwell's research on electromagnetism that established him among the great scientists of history. In the preface to his treatise on electricity and magnetism, 1873, the best exposition of his theory, Maxwell stated that his major task was to convert Faraday's physical ideas into mathematical form. In attempting to illustrate Faraday's law of induction, that a changing magnetic field gives rise to an induced electromagnetic field, Maxwell constructed a mechanical model. He found that the model gave rise to a corresponding displacement current in the dielectric medium, which could then be the seat of transverse waves. On calculating the velocity of these waves, he found that they were very close to the velocity of light. Maxwell concluded that he could scarcely avoid the inference that light consists in the transverse undulations of the same medium, which is the cause of electric and magnetic phenomena. The Maxwell relations of equality between different partial derivatives of thermodynamic functions are included in every standard textbook on thermodynamics. Though Maxwell did not originate the modern kinetic theory of gases, he was the first to apply the methods of probability and statistics to describe the properties of an assembly of molecules. Thus, he was able to demonstrate that the velocities of molecules in a gas, previously assumed to be equal, must follow a statistical distribution. In later papers, Maxwell investigated the transport properties of gases, i.e., the effect of changes in temperature and pressure on viscosity, thermal conductivity, and diffusion. In 1871, Maxwell was elected to the new Cavendish Professorship at Cambridge. He set about designing the Cavendish Laboratory and supervised its construction. Maxwell had few students, but they were of the highest caliber and included William D. Niven, John Ambrose Fleming, Richard Tetley Glazebrook, John Henry Poynting, and Arthur Schuster. During the Easter term of 1879, Maxwell took ill on several occasions. He returned to Glenlair in June, but his condition did not improve. He died on November 5, after a short illness. Maxwell received no public honors and was buried quietly in a small churchyard in the village of Parton, in Scotland. Thanks for watching. If you enjoy this video, give it a thumbs up and share it with your friends and family.